Next, I want to talk to you about dilation. And remember that a dilation can be an enlargement or it can be a reduction. So we need a scale factor when we are working with a dilation. So let's say that you are given ordered pairs, 2, 2, 6, 2, 4, 4. And I join those to make a triangle. And I ask you to dilate that triangle to a scale factor of 2. Again, in the beginning, when students first begin to work with these ordered pairs and dilation, you may want to set up a table where they are listing their x values and their y values. So for A, my x value is 2 and my y value is 2. For B, my x value is 6 and my y value is 2. And for C, my x value is 4 and my y value is 4. To get A prime, or the x value that goes with A prime, I'm going to multiply each of the x values by 2 and each of the y values by 2. So for A prime, I would have an ordered pair of 4, 4. For B prime, I would have an ordered pair of 12, 4. And for C prime, I have an ordered pair of 8, 8. And so now if you plot these ordered pairs and connect them, you have created a dilation with a scale factor of 2. So 1, 2, 3, 4, 1, 2, 3, 4. So this now is A prime as well. And then here is 12, 4. So that's B prime. So if I connect A prime to C prime to B prime, I have my enlargement with a scale factor of 2. Now, if I had a scale factor of 1/2, then I'm going to make a reduction. And I would take each ordered pair and multiply by 1/2. So A double prime would be 1, 1. And B double prime would be 3, 1. And then C double prime would be 2, 2. So if I go right 1 and up 1 is A double prime, and then right 3 up 1 is B double prime, and then right 2 and up 2 would be C double prime. And so now we have our little reduction for the pre-image. Both of these, whether it's a reduction or enlargement, is called a dilation. Also want to review with you now terms that we used a little bit with our billiard table activity, and that is symmetry. If you have a shape that you can fold onto itself with a vertical line, then it has vertical line symmetry. So if I take this shape, this rectangle, and I fold it onto itself, and the right maps to the left, then it has a vertical line symmetry. If I can fold from the bottom to the top and have it mapped to itself, then I have horizontal line symmetry. But now there are other lines of symmetry that we have to consider other than just horizontal or vertical, because we saw when we were working with our reflection that we could reflect across the line y equals x or along the line y equals 2. So now we need to consider other types of line symmetry that you could have. Sometimes we can have like a diagonal line symmetry, but now for this particular shape that's not going to work because my right half does not map to my left half. Alright, the next type of symmetry other than line symmetry is rotational symmetry. And for rotational symmetry, if I rotate this 90 degrees, it does not map onto itself. But if I turn it 180 degrees, it does map onto itself. So we would say that this rectangle has rotational symmetry because we can do a 180 degree or less turn and have the shape map to itself. Now, a pinwheel has rotational symmetry because when you rotate this leaf to here, they're the same size, so one would map onto itself. The shape would map onto itself. So if this had 10 flowers, 10 petals, 360 degrees is a full turn, but if you had 10 petals, then this would have rotational symmetry of 36 degrees or 72 degrees or any multiple of 36. Now, we did not talk about point symmetry. And point symmetry means that you can do a half turn and it mapped to itself. So this rectangle that we were using does have point symmetry because we can do a 180 and it will map to itself. So the three kinds of symmetry are line symmetry, rotational symmetry, and point symmetry. Okay, I want you to do this problem. This is a dilation. You have the ordered pair A, which is 2, 3, B, which is 1, 4, and C, which is 3, 6. I want you to dilate with a scale factor of 2. I want you to take the ordered pairs for A, negative 3, 4, for B, 0, 1, for C, 2, 3. I would like for you to reflect it about the x-axis and the y-axis.